I'm also to thank Ashutosh and his team along with the college faculties who are set up of backbone and provided us infrastructure for conducting this talk. So before beginning the talk, I would like to introduce myself. My name is Abhinav, and as Ashutosh told, and I started Compiler Sutra as an aim to provide a compiler tutorials to the beginner and to experienced people to learn compiler, not just like how the Dragon book have in a theory format, but in a way you can learn in a more modern way and more practical way. Because that's a very good approach, what I think. And along with that, uh, uh, I need to just ask one question. How many people are from compiler background? So that's what I assume. So that's why in before coming to SSA, I will start with the very basic of the compiler fundamentals so that we can be on the same page and just understand the things much more clearly. So I need to start. I'm going to start the meet now and recording. Recording started. So basically, as the SSA stands for static single assignment. As the name suggests, single assignment, you people can understand. What does single assignment mean? Getting assigned one time. That just keep in mind. We'll discuss it later. So first we'll go with the overview of the talk, what I will cover. I will first cover some of the basic part. Then what the real pain that part have. Then the compiler before SSA, what the problem they are facing. After that, how SSA provide the benefit. Then SSA in today's compiler, such as LLVM, and somehow we will also cover GCC, but not that in depth because I have most experience with LLVM, not with GCC. And then I will conclude on SSA backbone of LLVM. In the next talk, we will discuss about how a compiler actually creates SSA. So let's start. So let's see on your screen, I have seen share a terminal. If you see, what is it? It's a plain C code, nothing else. For any people who are not from the compiler background, they will see this code how? They will see this code as a plain text. Plain text with some symbols. Symbols such as opening braces, closing braces, semicolon. But this is not how compilers see. Compilers see every text in the form of graph. So at every stage of the compiler, first role of compiler is to convert into the form of graph. So let's see how compiler do that. If you, this ls command lists all the files in my current directory. So you will see only there are two files, right? Make file and one fundamental truth.c file where I have written file. If I will now run command, you will see multiple file has been generated. So at each state, compiler role is, so basically, when we say compiler convert source code to binary, I think that's a half truth. Basically, a tool can convert the source code to binary. That we can say much better way. So here, again, let me clear the screen. You will see .i file, .s file, .o file, and .bc file. These are generated in an order such that first .i get generated, then from that BC, this BC is called as bitcode. From there, IR get generated, then from there, assembly get generated, then from there, object code get generated. If you see the flag which I have used here, I have used -c and savetem. So what does -c say? -c say, hey, please stop at object generation. Don't go for linking and execution phase. Just stop at object code creation. And this savetem, what it does do, whatever the internal temporary file compiler generate, that savetem, what it does, it store it. So if you see, we have seen multiple intermediate format. So this -v say, show me the whole execution path and steps compiler is following, or the tool chain is following. So when I press enter, you will see huge text, which you will not able to understand. But if you will see clearly, here what you will see, this is the Clang compiler which I am invoking. Then after that, here at the stage, first it is generating preprocessor file. What does preprocessor file have? If you have ever written a C code, you write has define, has include. In that preprocessor, all come together in one place. And then from preprocessor, we get a object code. Where it went? See here, .i file, and then similarly you can see with the flag and experiment self, because here it is difficult. Uh, so here you can see .dc is generating second time, then here you can see .o is generating, and somewhere here .s file is generating. So all four occur sequentially. This sequence will always be followed. Now, what I told you initially, how compilers see the code as? Not as a text file, as a graph. So let's see how this graph gets generated at what stage. So here I have simple makefile rule, where here this command slang astf this not ast dump the ast. What is ast? Compiler generate abstract syntax tree. What does abstract syntax does? It shows the structure of your code flow. So I won't explain here AST in much detail. Just is the view idea I have taken it. It's today out of scope of today topic. So what I will do, I will just show you how AST gets generated. Here, this is the how AST look like. Can you understand it? It has become difficult to see this structure. So what we do basically, we create some graph visual to visualize it. So let's create a. So how this actually AST get generated? For generating the AST, we have used here flag C AST dump app syntax only. Right now, what we'll generate? We'll create a graph or better AST view. So for that purpose, when I write so it will give error that we need a compiler in draft debug base. So I have here two compilers, one is release and debug. So let's take a debug compiler. So this is the path of my debug compiler. Okay. Now is it visible? So here you will see there is one dot file generated. So this from dot file will convert a PNG image. So for that purpose, we can use this dot command. And if you open the PNG, it will show you something like this. This is how your AST will look like. Now let's come to the slide. So what is one fundamental truth? Our source code is a linear text, but compiler, what does it internally convert into a graph? So your code is like this. How compiler see? Compiler sees it as a format of a graph. So if you see the code, that code is very simple. If x is greater than 5, increment the y. If x is less than 5, increment the y. Or it's wrong, what I said. What is the code? If x is greater than 5, then what to do? Increment the y, right? If x is less than 5, then decrement the y. So similarly, if you see on your right hand side, there is one image where it's showing how the compiler will see it. Compiler will create a CFG out of it, control flow graph. Once control flow graph is generated, then it will see how data is getting flowed. So what two type of thing compiler is generating here? Control flow and data flow. What does control flow mean and what is data flow? Control flow graph, what does it say? It say how to go to the execution, how the code will execute, and what does the data flow will say? How is data is being processed? So one thing, again, compiler do not make decision based on a text. It makes decision on basis of graph. So you should be good in graph algorithms while dealing with compilers. So now you have what I shown you right now. We have a source code. From there we get a AST. From there we get a control flow, and then we get a data flow. So for that purpose, this is one command. Basically, people don't use it, but I will show you. Let's say if you've seen multiple times, whenever I was using command for the plan, not here, but so here, if you see, I am giving a target as Apple Darwin. So your machine will be different. So how to know your machine target for the C line? For that purpose, you can use command as -dump machine. So it will dump your target machine. So you can give -hyphen target flag for this to your machine while using it. So similarly, for creating AST dump, you can use xclang, AST dump F syntax only. And for AST view, your compiler should be in debug mode. So AST view will give that. Now you have seen this is how the AST graph will look like. So now one question I have to the audience who was listening. So what does compiler need to understand first? Control flow or data flow? Why? So, let's suppose you are driving a car. You are going from one place to another. Your source from destination. Your source is your home, and your destination you don't know. Means you know where to go, but you don't know the path how to trace it. So what you will do? You will sit in your car and do the basic stuff. Then put up on it your Google Map, and Google Map will create a directions flow. That is how control flow works. And your car is data. Then that data will flow. So basically, that's how the things work. So first we need to make what? Control flow. Without deciding how the control flow will move, we can't move the data. It will just be irrelevant to do. So that's why what the first compiler will do, control flow, then data flow, right? So let's understand a little bit about control flow versus data flow. What is control flow? We already know that. The program is how the execution will go. And what is data flow? The movement and transaction of how the value is getting changed. So if you see here, if you see there is a one blue color mark where mouse is moving. Can you see my mouse pointer? So here is X. Here is condition. Here is again X. There are three values of X. One is int X, which is garbage value, or it may be 0 depending upon your C runtime. So currently X is, let us suppose it's a garbage value. It will check, go in a condition, and then it will go in else, then it will return X. So there will be three values of X, right? X1, X2, X3. So what the first compiler will do, it will create a CFG like this. Your entry condition falls true. Then if X equal to 10, if X equal to 20, follow this path. If X equal to 10, follow this path. And then it change your data, trace your data. So what compiler will do? First it will create a CFG, then go for converting the data flow. So core question and some basic, just for beginner purpose, I have created this. So control flow, what does it ask? Where can execution go? Data flow, which value flow there? Then what control flow will represent? Program path, how your program execution logic works. And data flow, your value where it depends upon. And control flow will depend upon where? If else loop. And data flow, definition and uses, where we are defining and where you are using. So primary graph control flow will create control flow graph, and data flow graph. And control flow build from AST, and data flow build on top of CFG. Again, if you want to know the which data is coming, we have to again go and trace back the CFG, how CFG is flowing. Then only we can know where actually data is getting flowed. So complexity of control flow is easier to reason about, but data flow harder to understand. Control you can easily see, if else go there, but what about data? How to reason that? Don't think like we have a human, we can see it, but how to write a code which can figure that? That you have to think in that direction. Both have relation to SSA, it's required SSA, it's simplified by SSA. So now we know, right? Control flow tells compiler where to go, and data flow tells where to go. These are very basic. You should be at the same place because I will be using this term regularly in my talk. So that's why I was giving more discussion on that. So let's start. Let's discuss about the compiler before SSA and what the limitation was. First, let's again take the example of our code. See here, this is one definition of X. X is getting updated here. X is again getting updated here, and we are returning X. So don't think like a human being we can reason it if it will go in if block, it will go in else block. Now how compiler will reason it which block to go? So this was the real pain first, like variable which have multiple use case. It was very difficult for compiler to understand and to figure it out, hey, why the issue was and which value to take. of the X. Either they need to take 10 or they need to 20 or they have to return garbage values if it's not going in this block. So this was the first pain. Second pain was that, say, the value were implicit behind load and store. So there are two terms, implicit and explicit. Implicit means what? How you say? Let's say I am saying I will reach home at 8. It is implicit or explicit? Why? We are not guessing it. And it's implicit or it's explicit? So whenever when I say I will be doing a fixed duration, it means I am not guessing. Let's say your wife is at home. You told, hey, I will reach home at 8 o'clock. So she has fixed idea. You will reach at when? 8 o'clock. So she is not guessing when you will reach. You will reach at 8 o'clock. So it's explicit. When my wife will say, hey, if my wife says, when you will come, I will say, I will come after my office work. She has to guess time, 8 o'clock, 9 o'clock. Oh, manager told him stay in office. Then it will become implicit, or I am wrong. So basically implicit means hidden and explicit means whose value you already know. It's not hidden. Can you search it? Just search it. Just search on phone. Implicit means hidden. Means when I say you have to guess the time, my time is hidden between my office time. So that's what implicit is. Explicit means value is already there. It's not hidden any behind. Like I already given you time 8 o'clock. You can search this. So let us search till we continue. So that's what I'm saying. So here if you see, I have pointer and pointer is initialized value with 10. And then I'm again using in Y. But here is foo, I'm calling a function foo. So what here I'm saying, store 10 in X. And what here I'm saying, load X in Y. But do we know here whether foo, which X I need, it may get updated in foo? There are chances or not? There are chances. So we don't know which X is coming here. Either it may be updated one or which not. So if X, we are using the same variable, then again we have to go and trace back. Do trace backing from here, backtrace, which X is getting updated. And for again understanding data flow, we have to create how X is flowing. You're getting my point, right? To give the value of X here, we need to again create what? Data flow. How data will X is moving. So again, it's a headache for the compiler to do. Let us suppose when you are doing date code elimination, anybody know what is date code elimination is? Or constant propagation? What? What is not being used? How you decide that what is not being used? Yes, so that's correct. So the branch which is not what again? Not what? Not reached. The branch is not reached, we can remove it. So, but again, if you see, we have to again, if that branch is read, their X is defined, then again that optimization such as constant propagation and other may what happen due to this can affect it. So that's why a compiler needs some solution here, how we can eliminate or minimize data flow, not eliminate, minimize it, because we can't eliminate it. We can minimize that work because data flow we need to do. These are the two problems. Then third is control flow and data flow are tightly coupled. For understanding how data is flowing, you need to again go and see the control flow. So they are tightly coupled. Then data flow is becoming expensive because again you have to generate the CFG to understand So these are the some limitations of the optimization fragile. Fragile means less. Just I am changing little bit of code and it's modifying a lot of things, or it's not doing what we want. It's doing something else. So that's what fragile means here, and very hard to scale. So these are the some limitations. So now let's discuss what is SSA. What I discussed in the starting of the slide. What is SSA? What is abbreviation? What does here static single assignment means from the abbreviation? Correct. So by definition, SSA is that only. A single assignment is an intermediate representation. SSA is not any source code. It is generated by the compiler. So whatever intermediate representation before the assembly or before object code generation, compiler do, we call it IR mostly. It may be Gimple IR by GCC or RTL by the GCC or LLVM IR or other IR by different compilers. If you see, different compiler may have different IR. It's not that they will have same IR, but they may have semantically same IR. Some may, not must. They may have semantically same IR, but not syntactically. Syntactically means here I means wording, keywords, and the thing may change there. So what is SSA by definition? Is an intermediate programming representation in which every value is getting assigned once. Why it is getting assigned once? So that compiler can have better data flow and can understand the code flow much better way to implement other optimization and understand the IR. So now, this is your code. What I say by definition? Here, how many times I am using A in this code block? A I am asking, not B. Once or thrice or twice. On the podium. Okay. So here, A, how many times I'm using? No, I am saying how many times I have written A. That simple question. That not required any basic, just a common sense based question. 3, right? So out of which, how many are read and how many are write? Right? So if you want to convert into SSA, which will you care, read or write? Or both? Assignment matlab, if like I write A equals to 1, it means I am updating A by 1, so it's right. So if I am writing X equals to A, I am reading from A and writing to X. So for A, it's a reading, for X, it's a writing. Got it? So it's a both operation. From one variable we are reading, from other we are writing. So if you want to convert to the SSA, how it will be? A will become, we want single definition of each variable. So let us define whatever A will come as A1 and B1, and second time when it will come, we will update to A2. So here int A1 equal to 10, B1 20. What about this if block? It will get updated or not? If block. So A1 is 10. What about if? A1 only, right? Because why we are doing that? To understand the data flow. A is 10. So if you make it A1 as 10, so we are not updating here A. We are just reading the A. So while reading, what we will use? Last updated value. So last updated value of A is what? 10. So it will become like this: A1 10, B1 10, A1 greater than B1. Similarly for other variables, which you can understand. I think if people understand, I can move forward. No need to explain the variable, right? So again, compiler will generate a graph out of it. Compiler will generate a graph, right? So what is the static? What do you mean by static and dynamic? Right? Whatever things you know during compile time, we say mostly static. So when you write static single assignment during compile time, we do it. It simply means. Okay. Yeah. So what compiler has did? It's created a block of your code. Block. And see here, if you see, I have written some PP0, PP1. It's not what we basic block it is, abbreviation is basic block. What is basic block in compiler? When you are moving from a straight line without any break, it's called a basic block. So let's suppose from here, I am moving from A to C, int A equal to 10, B equal to 20, then C. Then after that, I am diverging my path. There will be two paths will be created, right? So basic block is what? A single line of sequential code is called as basic block. So here the code will break in each block from if the code will divide in two parts. So this A, B, C will be in single block. Then if two block will be there. For if again this will be basic block will be created. And for else this basic block will be created. Other code will be where other basic block will be created. So what does compiler do? Every sequential for every sequence of the operation it creates a basic block. Whenever there will be branching, whatever I mean here by branching, condition comes. Even loop is a condition. So whenever condition will come, then what will compiler do again? It will again generate a separate basic block for them and create a graph. Here, how graph will create? You know, we will create address reference from this go to there. I will show you in IR how it look like. So now, why need compiler need SSA? Just think of this single code. I have used your volatile, just forget it, because now the nowadays compiler are more modern. To get you what I needed, I have written test in that way, so that I can show you how it works. So if LLVM basically, instead of if else, now LLVM use select operation, not as create a graph in more optimized way. So if you see this code, what the value of x will it return? If x equal to a plus 1, b is greater than 0. If b is greater than 0, it will go in if block. Then it will return x plus 2. For you, it is easy to reason, right? But for compiler, it will be difficult. So what compiler will do? Convert into a SSA. So before SSA, this is how your IR will look like. There are multiple load stores. If you see here, before SSA IR, what you are seeing? Load, it's LLVM IR is of two types: memory-based IR and register-based. The memory-based IR of the LLVM, is not complete SSA. It's a we can pseudo SSA, but register-based LLVM IR is 100% SSA. We will see which paths do that. So here, if you see what we are doing, we are allocating space to variable $2 or %2, then allocating space to %3. Then here we are storing it, right? So here, so after SSA, how it will become? You will have different. For each variable, there will be new variable name will be created. For each variable, new name will be created. I will show you this in terminal much better way, this explanation. I have just created to create test case here. There is no use, just to showcase the example of, because nowadays LLVM compiler is more modern. If you write simple code like this, they will, instead of, when you optimize it, instead of creating a file node of SSA, they will use select operation and other thing. So it is very difficult to show that thing. So to make the code a little bit complex, I have used this. So here let's see. See, this is the way I use -s emit LLVM is the command to generate the IR from the LLVM. So what happened at each optimization level, multiple passes run on LLVM. So to see each pass, say what happened, I will show you. So how the compiler works basically, you have a C code, it can convert to, let me show it. You have a source code. this source code gets converted to from preprocessor to .i. Then from this preprocessor is given input to compiler, and this compiler convert into .s. So now we will open this box. We will open this box. So let's see. This is your now .i file. This is your compiler. So compiler will generate what? First, tokens. Using Lexer, they will generate tokens. From tokens, what they will have? From parsers, they will have parse tree. Then from their semantic and sequential analyzing, what they will have? IR, intermediate representation. And what now? From now, this IR is non-optimized. What is this? So multiple optimization passes will run on it till when we get .f file. So we will see. So how to know all the type of passes run on this IR? How to know? So for LLVM, there is a flag. See, in LLVM, there is a flag print after all. What does print after all do? It dumps all the optimization passes and what they have changed in the code. So basically, it dumps on a terminal. It won't redirect into a file. So what we will do? We will redirect into a file. So if you see how many times IR dump after is coming, around 58 times, right? So that much optimization compiler has run. So you can simply, to see all the name, what I mostly do, if you will do like this grep, it will dump all the passes which compiler has gone through, which is very difficult. So let's see what I'm talking about SSA pass. So what I will do, if you'll see, here is a file node, IR dump for I think I have did on O2. Okay, I didn't optimize it. Even on O0 it is. Let me optimize it on O1. So again, number will change. So now we will see there is one SROA pass, right? Before that SROA pass, you will see here. See, what does it mean? Basic block. It will create this basic block, and then it means you will see label, and this you will see label 18. So here, if you see BR instruction, so what BR is saying, either jump to 12 or 18, depending upon how 11 is. What 11 is doing, it's comparing 10 with 0. If you see the code, what code is b greater than 0. So here 10 variable, it's comparing with 0. So that condition is here. If statement, we are dividing on if, right? So if b is greater than 0, so that what is here happening? %11 compare I32 10% 10, 0. So this register is getting compared with 0. And if you see before, we are using what? Allocate. So now if you here see in different basic block, there are like how many block are there? You can see 1, 2, 3. So in the what you are doing here, you are storing %9 to %7. What you are doing here, you are again storing 17 to 7. Now it's difficult for me to see. So you are seeing multiple values are getting assigned at same time, right? So it's not in pure SSA. Why? %7 is store means we are right. What I told you about SSA, x equal to A, x equal to B. It means I am storing A in X. Again, I am storing B in X. So this will be lost. So what SSA say? Let's x equals to x1 equals to A, x2 equals to B. So what we are doing here, instead of x, let's say %7 is there. So what %7 we are doing? We are here storing 9% 9 to %7. Here we are storing %17 to %7. So that %7 older data will be lost. So that was the problem with the pre-SSA. So if you see this SROA pass, initially LLVM used mem to rec to convert it to SSA, but that's logically correct. But now more updated, they have put more code in SROA pass. It handles that all these things. We will discuss more about that. First, see how it is happening. So here we see what it has created a phi node, and it's saying if this is true, if I is comparing with 0, then % branch to either level 6 or 7. I will show you by graph also. So what does it's deciding on the basis of %9. This phi node is deciding which path to take. Either you can see here in the code to update the X value, either you have to go inside if block. If you are not going if block, you have to take from this value. So here, this is decided by this phi node. It's saying if result is coming from %7, if result is coming from this symbol or this block, then use %7. If result is coming from block 3, which is this, then use value of variable as 4. This 9 will become 4. 9 will have two value. What? Either 7 or 4, depending upon from which block it is coming. That is decided by 6 or 3. So if you see here, what we have did, our control flow has been split from b greater than 0 and then x equal to x plus b, then return x plus 2. So just forget about memory read and write. That's just I introduced to show you these optimizations. So now what compiler has to reason? It has to reason about two things: load store and control flow. Control flow we know, it even non-SSA it works. But for load store, what was happening? Values were getting overridden. With SSA it was not happening. So that's how each works. Now I will discuss this later. Let me discuss this first. We are at this place, right? LLVM IR. So we have seen our plain code first converted into parser to AST, then LLVM generated IR. Initial LLVM generated which IR? Memory based IR. Load store one which I shown. This if you see right, this one, these are load store IR. Then after this SROA pass, it converted into the SSA. But before that, it was in memory based IR. Mem to rec was old now. Initially it was mem to rec, but now it moves to most of their implementation moved to SROA. Memory based IR means you are taking data from the memory, not from registers. You are creating the memory, then you are storing their values instead of in registers. Yeah. So initially, see, initially LLVM convert memory based IR. Then on that it run multiple passes to construct SSA. So that initially was handled by memory to rec. That pass role was to convert memory to register and handle SSA. But later LLM involves and they have given most of their responsibility to SROA pass. We will cover that part also. What the SROA pass does. So initially LLVM was mem to rec, but now it's SROA. You can even see from the print after all. So here, if you see from print after all, see, this is your memory based IR, right? From simplify CFG, right? If after that SRL pass has been run, and then it's converted into the register based, and it's your converted into what you say, SSA based IR, register based IR. Yeah.
The memory based data, is there any access to a variable would be
I didn't get your question.
So even if you get access to the variable, the IR would correspond to this data.
That's way, but I will answer one question by this example. Let us suppose this is the memory. Somebody written here 10, and other variable 10 here written 20, other variable written 30. How will you track what was before 20, 30? How will you track? You have again to see data flow, you have to see, or you have to see control flow, how the flow is going. So it will create headache. So instead of memory based, why not we convert to register based? And assign, see, LLVM registers are virtual registers, they are not real registers. So they can be infinity numbers, right? So if we are assigning every variable as A1 equal to A, A2 equal to B, then we don't have to trace every time what is the value of this variable, because we can see from that particular control block itself. We don't have to depend on previous control blocks, right? So that way how data flow become simplified, more easy.
And if you compare this with I've read that each IR is SSA. So
I have a each value will be, yeah, that what I put. Each value is SSA, not IR, I think. Yeah.
So there is an equivalent of this memory.
We can take it offline, because I doubt it's what you said. Yeah, that was said. I am doubt about that, because I don't have. See, I have experience in LLVM, not an MLIR. So like people comment as LLVM SSA is also on. We have seen in multiple blogs they write that it's a pure SSA. But even if you ask ChatGPT, some of them reply it's pure SSA, but it's not pure SSA. Memory based is not pure SSA. I can prove it right now. So memory based is pseudo SSA, and your IR is register based SSA of LLVM is pure SSA. Even GCC have their own mechanism, Gimple IR and RTL IR. So Gimple IR is SSA format, but RTL is not in RTL SSA format. Yeah, RTL only. Yeah.
Why is the memory based IR can be directly from AST directly generated?
You can even from AST generate the directly assembly. But see what happened. Memory based IR, I am not sure why it is necessary, but you don't write how much memory you need to give during time. Let's say sometime, I am not sure about that question. I can answer it later. No, his question is why we need memory based SSA, why we can't. Okay. What he want to convey that we don't need every things to be in SSA format. That's when we need SS, but yeah, LLVM IR. Yeah. So I think even, but now they are mostly in SSA format. So I think I need to get better answer for it. I will take it mine. I will reply. So now if you see, which currently mem2reg is there initially, but now SROE pass which do it. So you have a C code. It will first convert to memory based IR, then SSA format. This is C, this what I've generated with the more optimized level. So that's why it's not showing the 5 node another thing. A more optimized level. So your if else become select and new instruction, anything can come, nobody knows. So I will show you how to generate here. Let's see how to see CFG for this first, then I will come to SROA. Okay. So we have seen this right after SROA. This was our code. Now, how to see the control flow for it? So here I have a IR. So what I will do, there is OPT command. What is OPT? OPT is LLVM middle end. Means upfront middle end optimizer. So when you are running any IR, what OPT do? It will show you the same flow what Clang and other compilers following to give you the debug the optimization passes, and same LLC for the backend. So let me generate. I see I have a ll file as input. What is name? out.ll. So I will give out.ll as input, and it will generate. Okay, sorry, this was not command. Hyphen process. Initially, there are two type of LLVM pass manager: legacy and new pass manager. In legacy pass manager, this command have worked, but in new pass manager, it won't work. I need to give one more command. Why VLAN is good? No, actually, I think no. Here, actually, I need to give one more command. That path of the sys root. Yes. So here, if you see, it will create a foo.dot file. So again, that dot file converted to PNG using this dot command. Then you can take any PNG format. So here you will see the. Can you see it? Right. So this is same in the PPT, but more related to this. So we'll discuss about the same way you can connect there. So some optimization. So here, what you can see, if true, then come here. If false, come here. So if it is true, then if you see here, this %9 will need to tackle a data. This computation is different. What I32 will return 10. So 10 will get value from 9. 9 will get value from this 5 calculation. So if it was not in SSA format, then the data what should be come here, apart from this CFG, compiler need to check other global level, like somewhere it may have, in different file it may have done. So again, they have to create data flow analysis. So it is very difficult, but now it's easy. If it is 7%, 6%, 7 means, if what does this notation means, %7, %6, if it is coming from block 6, take 7. If it is coming from block 3, then take 4. Right? You're getting? See, there are two blocks, 3 and 6. And here 9. 9 computation will depend upon where. If data is coming from block 3, so here on the right hand side is written 3. Take value as 4. Else take, if it is data is coming from block 6, take value as 7. So it becomes easy. So compiler convert into SSA format, that's why. So you see, this is the command to convert to LLVM IR, and you can use this -passes equal to .cfg to convert to CFG, and you can check it. So now question will be in your mind, how LLVM, how compiler used to tackle it before SSA. If SSA, it is not modern concept, it comes in early 2000, I think, or 1900. So how do compiler used to tackle it before? I will take that example using GCC. Right? Let's take a simple example. Here, if you see, I have a simple example. So, what x value should compiler give from here? Return x. X has how many value? 3. X, which is garbage value. If what here, if c means if c not equal to 0. If c is not equal to 0, then go to 10. X go to 20. Right? This is the only way, or any else. So what GCC? Let's see how. If you want to do same thing to PIR and CFG with GCC, we will see here and see how before SSA compiler is to solve it. So again, the same logic of what I told you. Every passes will run. Same passes will run on GCC. So GCC have two type of passes. Which one I told you? RTL and Gimple. Gimple is front end pass, and RTL is they're mostly back end related passes. Or to what we can see, in order to see most of the optimization pass run by GCC, we can use the flag. See, this is the flag fdum triol. If you see now, I have only 2 files, right? When I run this, you will see how many files has been generated. It's a simple code, right? So what happened in LLVM, most of their passes are dumped in one file. But in GCC, for every optimization pass, a new file is generated. And they are numbering sequentially, like first pass, then 1, then second pass, then 2. Some of the optimization, if they have skipped, they don't get name. So if you see names such as 0, 6, 7, 10, 11, they are in sequential order. If you see, there is one pass as SSA, one pass as fix up CFG, which is before SSA. So let's see that. So here, what it is returning D.4469. What D.4469 have? X. If you go above, X have 2 data, 10 or 20. Which to take? How will you know? So what you have to create here again? How will you know? These are ambiguous, right? X equal to 10 and X equal to 20. They both are ambiguous. So which X value should we take? From SSA, we have idea, right? If it's coming from this block, take this data. If it is not coming from this block, take this data. So how before SSA? So before SSA, it was difficult. So what again you will create here? Again, you have to data flow. How what X value is getting updated? You have to do global data flow analysis here. What? Global data flow analysis. So there is one algorithm, rich definition. Which definition variable is? We will see that. Like there are multiple options. One way was that defined variable. You just see how many time variable has been defined and then undefined, undef chain. That was an algorithm. Then there was this rich. This was the which I am going to share you. It was the most reliable source at that time. So you got the problem, right? What's the issue? Which X equal 20 and X equal to 10. So they are ambiguous. You know, right? What is the meaning of ambiguous? What? Confusion is ambiguous.
It's not exact.
Not exact is ambiguous.
Multiple options, like
If you have multiple options, it's ambiguous. Means when it becomes difficult to chase data, get the data. So it's ambiguous. So
can you show that
yeah, I show you that. That only I am sharing. So here, see what it has done. It has created again GCC IR. If you see, the logic is same. Here, the notation are different. Return 5 5 equal to x plus 1, x1 equals to 5 of, if from block 3, take 4, if from block 4, take 3. X underscore 4 equal to x underscore equal to 3. So this is GCC IR after SSA pass. So the same variable is stored in multiple blocks. If you see, your source code was x equal to 10. It's stored in with multiple names. X equal to x underscore 4, then x underscore 3, then I think underscore 1 it has used here. So only they have linked name, right? No repetition of the same variable name. Then even we are following the different control flow path, but still at this location we know from which control flow we have to take the value. That was what benefit. Then the extract value is now not explicit, it's implicit. So compiler no need to like see, even it's reaching here, they no need to assume the definition, they can get it. I think I have written it wrong. Compiler multiple possible reaching definition. I think this is a wrong statement because compiler already know from here. I think here I mean here why I have written this compiler multiple possible reaching definition. See, just compiler has to tackle which definition is coming here. So out of two, one will be chosen. Then what this compiler has you? Compiler, even though it has multiple definition, it takes only which is relevant to that particular block. Relevant to that particular block. If not relevant to that particular block, it can take data from previous one. If you can see from here, it can easily know, hey, go in this loop. If let us suppose there will be if else block in continuous, what will happen? Multiple CFG will be generated. From each block, you can trace back. You don't have to again create a data flow analysis from top. You can go from bottom to top by tracking the each CFG path which he has followed. What the value of X will be. And now optimization, what will happen? It can be easily pass the value which is more semantically correct, which I will cover in next talk while explaining how SSA get converted. So now I will also cover one thing. See, you will see the pane here. See, reaching definition analysis. Let us assume you don't have SSA logic. SSA algorithm you don't have. How to do? It was developed by some people in IBM during 1990. I forgot his name. I written on my blog. He has developed. Means IBM team has mostly done research on it. They have come up with this approach. So reaching definition analysis, what it is? So it tells compiler which assignment of variable could be available during that particular moment. Let us suppose where we are facing problem during that fifth block, which was our pain point. This block, right? What to decide? So at that particular block, what value of the variable will be? This is decided by what? Initially reaching definition analysis. So what does RDA will tell? The assignment of variable at that particular point. Particular point, what I here mean by, if see where we want to give value. Here we want to take value, right? We are for that we are tracing back. So RD will give exact value at here. It will create some mathematical equation, and from there it will give a value. So that how it will look like. So it was the only best solution available before SSA. So see, your code is there. Now question is which value of X should be here. So how it will over? We will how it works. So see, basically what we'll create here, we'll create a control flow graph and data flow equation we will create. And in that, see, let us suppose if X is returning two value, X equal to 10, X equal to 20, then we can store it in which data structure, so that only we will have the value. Like set don't have multiple values. But now the problem is again, which value should we take then? If X is multiple time defined, how will you take? So for that purpose, we have to iterate over whole CFG and see which is the latest updated data of the X. We will take that. Repeat ultimate, we have to repeat this same logic again and again till we reach any fixed point. So let us suppose if input change, if C is 0, C, if C means if C not equal to 0. So what does it will go? If C is equal to 0, where it will go? 20, right? If C equals to 0, it will be true or false?
False.
So false will go where? 10, right?
Depends on this one's true, which is false.
No, left is false and right is true. Then let's say left is false and right is true. 10, right? Basically, that's how the flow, if else we write. Okay, no worries. So here we will create some mathematical computation like this. X equal to 10 and 20. Where? I said, let's say, assume C is 20, 0 then. Oh, my question was that if C is 0 then. Else, right? So, no, yes, don't confuse between color. Color is different. Acha, in code. Okay, yeah, code it will go in 20. Okay, I may have created a different diagram. I was seeing the diagram. So here, see here, x equal to 10, x equal to 20, it will iterate till any fixed value is reached. So fixed value will be written on how? Value of? It will depend on value of C. So we have to do that when the value of C will be available, during compile time or runtime. Runtime, right? Runtime. But in SSA, we know it at the compile time. So during compile time, if we are getting the value, we can enable more optimizations by giving two different passes of the optimizations. So this was one of the more drawback of it. So similarly, that sir has asked me just CFG data. So let's say for if you want to create a graph or that graph of SSA using GCC. So here is a GCC command one tree SSA.graph -graph. What it will dump? It will dump again. It will dump this SSA.dot file. SSA.dot file. So again, the dot file can be converted to CFG using dot command. So it will show the graph like this. So I hope you people understand why SSA needed at least little bit idea.
In this case, how does C become static when it's SSA? Still runtime value.
Where?
C. Imagine C.
No, here C data will be different runtime.
Yeah.
It is dependent, right? C can be lost. It is dependent, right? C can be lost.
It depends on how you written code, right? If you have defined C equal to some value, you can know at compile time. But here in this code, we don't define C anywhere. But we have use X, right? So if we have written 6C equal to 10 somewhere, so we know at compile time. But if we have not written C any value, we are taking input from the user, then what that time will happen? It will be known during compile time or runtime. It will be known during runtimes, right? So most of the source we don't do it right. We mostly give it to the customer, they use it. So for them, it will always be runtime if that data is not duly available. Let's say you are checking some condition based on, it's all depends on how you are written code. It can be available on compile time also, at runtime also. So, but what as a compiler guy we need more of the data during compile time. So that if we are getting more data at compile time, then we can again think of it how we can use data to make it more optimized. If we are getting data at runtime, it is very difficult to optimize those data, right? So that's what I mean here. So it can be both static or runtime, but in this case, as C value we don't know, it will be at runtime. That's what I mean by runtime. So we have seen SSA in LLVM. Now we will come to SROA, what I discussed with you. So SROA stands for scalar replacement of aggregates. What is aggregate means? Any idea? So any data structures or any collection of data of fixed shape or size, we can say aggregate. So structures, union, array, all become aggregates. So what scalar replacement of aggregate does? I don't know what GCC uses. I know what LLVM uses. I am not. I have not worked in GCC that much. So basically, what this SRO does, it breaks aggregate stack object such as array into individual scalar values, and then eliminates unnecessary memory operation. So as its role was to eliminate unnecessary operations such as remove loads to other things. So LLVM people want to minimize their number of passes. Why? You have seen a single code has written 58 passes. So if more passes will be there, then what will be the challenges will be there? Compile time will increase. And I don't know, but sometimes you have to run a code for hours to get compiled. So people want to minimize that also, compile time. So for that purpose, from mem to rec, they move to SRO. That one was asking. That's my assumption. Why they moved is my assumption. So replace them with direct SSA values. Then convert memory-based. One more we need to convert memory-based code to SSA form. So decisions are based on 5 values and make value flow explicit and enable real SSA for our local and compile time. Right? And so what does SRO do? It removes the stack memory. What does stack memory mean here? What we are allocating to this alloca and other things, right? And by replacing with a scalar and making value flow explicit and optimizable scalable. So we have seen that CFG. So how SSA benefit now we know, right? Why didn't get to a question? Can you be louder? Exact. Achha. Inside SRO means what? Yeah, I think now it's a part of modern SSRA. It's take that modern LLVM SRA part. Yeah, initially it was meant to rec, but I don't know in which version they have moved. I think 17 or 18 they have moved. I'm not sure. In some of the version they moved it to SROA, but I don't know the version name exactly. So how SSA benefit? Single assignment for means you should have a single assignment for every variable, right? So there will be a single truth for a data, and there will be no guessing of the data. There will be explicit data flow. You won't be guessing data during runtime. You will be knowing it, what the exact value is coming. So compiler don't construct from load store. They construct from the register values. Then a file node will handle the control flow easily, and merge value that merge. How merging means combine two values into one. So merging value will become more explicit instead of implicit. And what we will have a local analysis instead of global analysis. What initially we are doing, we have to analyze whole program to come to a particular variable values. But due to SSA, what is happening? Only we need to analyze those particular blocks, and optimization become what? More is doable. More and more number of optimization is now possible due to SSA. So let's see how SSA, the complete flow of the code. We have a source code here. This source code, what we get? AST. So this AST we get initially LLVM IR. What is initially LLVM IR means? Memory-based LLVM IR. So SSA construction will start. Build first. You have seen before SSA there was one pass was running. Which pass was that? Simplify CFG. So build control flow graph. Then this is the algorithm dominant and front trias which SSA use to construct, compiler use to construct SSA internally. So then insert the file node at joint point. What does it mean by joint point? Where we have to make a decision, where we don't know the data. Then from here we convert to LLVM SSA, and other optimization passes are running. So these other optimization passes is given to the they get the SSA data. Then this constant propagation, data code elimination, deviant passes, LICM passes, all the passes get run. And again, at each pass, we validate where LLVM is in SSA or not. So all this makes it in pure SSA format. If we remove this initial some passes before SROI, all the mostly LLVM passes are in SSA. So this is why I say SSA as the backbone of LLVM.
What does it mean for a pass to be in
What it mean by pass to be in SSA is that, see, if we have a x equals to 4, x equals to 5, x equals to 8, x equals to 7, right? And let's say we have each cases equals block. So let me write it in C format.
You mean it preserves the SSA form?
Yeah, it's preserved SSA form. Means every variable will be assigned once. That's what is preserved. Let's say I have created a basic block, x equals to 4, x equals to 5. So here it's not preserving the
Once every all assignments are separate between the pass should be talking of what SSA is, what SSA is.
what do you mean by separate by what?
Yeah, that's separate.
Let's say I have IR %1, %2. Then what should I?
It's just %1, %2 for the IR.
Correct.
It does not have any relation with whether those.
But let's suppose I am using %5 here, and again %5 here, and I am storing this %3 value here, and again then IR can't be %5, it should be %6. So that's what I mean by preserving the SSA form. Yeah, because every time whenever you are using any new variable or the same variable definition, or let's say same variable is getting assigned to any new values, then that variable will not store in those variables. A new variable will be created or new.
Is there a data structure which stores the information about the mapping for a variable to all its assignments?
I think the LLVM is a dominator. It compute SSA explicitly computed is dominant, and there are some diff and undiff data structures are there. Undiff and diff data structures we use for that to track all these things. How to generate SSA.
Undiff data.
Let me.
I think this question is how do you map source level variables to SSA level?
Is it stored somewhere that these are all the assignments of the same variable?
Diffuse variables are used. Diffuse variable. What is basically? We see how many times variables are getting defined and where are they being used. So that's why it does that. It will create a dominance tree. Then it will use diffuse algorithms to do that. Which I won't take it. Yeah, there are. Actually, that I was taking in our next talk. So that's because it will become too used to take in this talk. So this was just beginner friendly design. That's why I didn't go there. So that's how. See, these are my next talk or topics. So file node, see, even if you go in that register allocation, there also file node are being used. So during conversion of LLVM IR to MIR, the file node getting resolved. Is there any specific? Yeah, destructor. SSL destructor is there. File node. You see here PHI. This is the file node. Yeah, which node to, which block to take. So we know how SSA benefits. So we discussed this. So now LLVM IR is basically value-based representation. So memory-based IR is basically of LLVM get promoted to SSA early in the pipeline. And SSA, what is enabling data flow explicit? Initially it was implicit. Most LLVM optimization assume and preserve the SSA. What I mean here by preserve SSA means if you have seen right 6%, 7% rate, so you may have seen LLVM IR. So they preserve SSA. That's why you see like that. They are already in SSA bomb. That's why. Yeah. So this what it happens is enable and more optimizations. So see here I have written SSA is preserved until late backend lowering. So regarding a question, when this backend lowering getting stopped, so mostly I think register location is a pass from where it gets start, because once register got elected, so from LLVM IR we convert to GMIR, from GMIR to machine IR, or yeah MIR. So during that phase, it's somewhere it get deleted.
So basically, memory based IR is for a table.
It's used. I'm not sure why it is used, but
Memory based IR, they need a separate path that will convert memory based IR to SSA.
yeah, SROA pass. Initially it was mem2re, but now it's SROA.
Easier for the front end to lower.
Yeah, easy to lower it. Instead of debugging, we can say lower it.
Analysis and object transformation, they also operate on memory, right? For example, alias analysis.
They on both register memory, I think.
It says operate on values and not memory.
Analysis and transform passes, yeah, they operate on values. I never seen any pass operates on memory. I've seen on mostly on values, so I mentioned that. If you see any of what this analysis and transformation do, they only happens after the SSA got generated.
There's no analysis.
That's before creation of SSA. So, but mostly what happened when you are optimizing it, you optimize SSA based IR. So, obviously, the analysis no sense of creating memory based, right?
So, for example, if you have pointers in LLVM IR,
Pointers get, I think, typed if no. There is one keyword for that in LLM. Pointers are there, but again, what I mean here, operates on value, not on memory, is SSA format I'm saying. So SSA, again, it will convert memory based SSA. Value based SSA will be converted to memory based SSA in pointers, I think, yeah.
This dominator tree analysis is used for finding these population power.
Yeah. So the same we use here for SSA, which variable to assign the value to the tree. So there is combination of multiple algorithm, undef, def, then dominance tree. They combine together to generate one algorithm. If you want, I can share you the research paper link. So how? So basically, now I think I need to conclude here. So what we from this talk we came to know that compiler reason about program, control flow, and data flow, not source text. Second is what SSA is enabling, well, data flow as explicit instead of implicit to enable more scalable optimization. So our optimization such as constant propagation become simple one is SSA available. Once this SSA get available, then only it was able to implement. Then SSA do not see one question would be is SSA optimization? No, SSA is not optimization. It's just a representation format. So what I'm thinking to take next talk on is how compiler construct SSA and all the data structures such as def use chain, why they matter, and dominance tree and pi node. Your question, how they convert to register location and how actual LLVM implement SSA. So anybody have any question? It's compiler generated internally for its analysis. So if compiler is generating it analysis, it don't store on your, see, storing means it won't store on your hard disk. It will run time, but it will have data. Yeah, from RAM it will be discarded. Let us suppose you run any, it only generates temporarily.